Hi everyone, thanks for joining me on Non-Conventional Energy Sources video presentation. My name is Pravina. I am a student at Sri Venkateshwara College of Engineering, Bangalore, Department of Computer Science. In today's video, we are going to be discussing on the topic photovoltaic applications. So, let's get sailing. Before getting into the video, let's know what is photovoltaic. Photovoltaic is a conversion of light into electricity using semiconducting materials that exhibit photovoltaic effect. A phenomenon studied in physics, photochemistry, and electrochemistry. PV is a method of converting solar energy into direct current electricity using semiconducting materials that exhibit the PV effect. A PV employs solar panels composed of a number of solar cells to supply usable solar power. PV installations may be ground mounted, rooftop mounted, wall mounted, or floating. The mount may be fixed or use a solar tracker to follow the sun across the sky. Power generation from solar PV has long been seen as a clean, sustainable energy technology which draws upon the planet's most plentiful and widely distributed renewable energy source, the sun. How do these systems work? The light from the sun, made up of packet of energy called photons, falls onto a solar panel and creates an electric current through a process called the photovoltaic effect. Each panel produces a relatively small amount of energy, but can be linked together with other panels to produce a higher amount of energy as a solar array. The electricity produced from a solar panel or array is in the form of direct current DC. Although many electronic devices use DC electricity, including your phone or laptop, that are designed to operate using the electrical utility grid which provides alternating current AC. Therefore, in order for the solar electricity to be useful, it must first be converted from DC to AC using an inverter. This AC electricity from the inverter can then be used to power electronics locally or be sent on to the electrical grid for use elsewhere. Let us know more about the solar array. What is a solar array? The most important part of a solar panel system is the solar array. It holds all the panels in our system, which is where sunlight is collected and converted into electricity. How do solar arrays work? Simply put a solar array in a collection of multiple solar panels that generate electricity as a system. When an installer talks about solar arrays, they are typically describing the solar panels themselves and how they are situated, aka the entire solar photovoltaic or PV system. To create solar energy, sunlight needs to be hit to your panel's PV cells. The sunlight sets electrons in motion, producing direct current electricity. Your array is connected to an inverter or multiple inverters which convert the DC electricity generated by the solar cells in your panels into usable alternating current electricity. Getting back to the main topic of the presentation, photovoltaic application. There are many applications of photovoltaic, but few are listed here. They are solar farms, standalone power, power in space, military uses, transportation, building related needs. Jumping into the first one, solar farms. Solar farms are large ground mounted solar installations. Solar farms utilize photovoltaic panels or other means of a system that collects solar energy to make better utilization of sun's power. The land of 100 plus acres solar panel arrays considerably generate more energy. However, 30 to 40 acres allow us to build 5 megawatt solar farms. The power generated later is collected, then connected to the grid and redistributed. Standalone power. In urban or remote areas, PV can power standalone devices, tools, and meters. PV can meet the need for electricity for parking meters, temporary traffic signals, emergency phones, radio transmitters, water irrigation pipes, stream flow, remote guard posts, lighting for road, and many more. Power in space. From the beginning, PV has been a primary power source for Earth orbiting satellites. High efficiency PV has supplied power for ventures such as International Space Station and surface rovers on the Moon and Mars. It will continue to be an integral part of space and planetary exploration. Military uses. Solar power will continue to play a significant role in the military installation. With the help of solar panels, the military can generate its own electricity, reduce its dependency on the grid, and protect its installations from power outages. The military can also use solar power to power its equipments, vehicles, and reduce its dependency on fossil fuels. Transportation. PV can provide power for vehicles such as cars and automobiles, boats. Automobile sunroofs can include PV for onboard power needs or charging batteries. Lightweight PV can also conform to the shape of aeroplane wings to help power high altitude aircraft. Lastly, building related needs. In building, PV panels mounted on roofs or ground can supply electricity. PV materials can be also integrated into building structure as windows, roof tiles, or cladding to serve a dual purpose. In addition, wings and a parking structure can also be covered with PV to provide shading and power. I have now come to the end of my presentation. Thank you. Thank you for your time. Until the next time, adios.